Hello and welcome. In this video, we're going to take a look at solving a couple types of equations. We're going to look at linear equations and quadratic equations. And there's a couple basic principles that apply to any equation. So let's start off with those. There's a couple major properties whenever you have an equation that we're going to apply all the time. Now, an equation is whenever you have some sort of expression on one side of the equal sign and some expression on the other side of the equal sign. Now, on its own, an expression is not really complete. It is just something like 2x squared, which on its own doesn't mean much. It's just a bunch of operations put together. The moment we stick an equal sign in there, now we have a complete sentence. Some expression, some variety of operations gives you an equivalent value to the operations on the opposite side of the equal sign. So that's what turns an expression into an equation, is when we start putting an equals in there. Now there's two major principles that we can use on any type of equation. Now the first principle is the addition principle. And if you think of an equation a bit like a set of scales, and we have both sides with equivalent weight, A weighs the same as B. Now, without tipping the scales, we can go ahead and we can add some amount on both sides. As long as we add the same amount on both sides, everything remains balanced. The addition principle says that if we have A equal to B, then we can go ahead and we can add C to both sides, where C is any real number. That means C could be negative or positive. Any real number. And so if you make C negative, we can think of the principle of addition as basically being subtracting something from both sides, so long as you do the same to both sides. Now the multiplication principle kind of works the same sort of way, except that rather than adding any value we like to both sides of these set of scales, what we can do is, if we know that A and B have equivalent weights, then we can go ahead and we can actually take 4 of those A's. So that would be 4 times the weight on one side. And we know that that's going to balance with 4 B's on the other side. 4 times the weight over there as well. Then the scales still remain balanced. Now, we could take 5 A's and 5 B's, or we can take 20 A's and 20 B's. As long as we have the same multiple, then both sides have equivalent weight. So, the multiplication principle says that if we have A equal to B, then taking some scalar multiple, some scale of A, and some multiple of B, which is the same value, then the two quantities are still equal, with a very important restriction. C can be any non-zero expression or any real number, not 0. Okay, now this goes just beyond real numbers. A, B's, and C's can be expressions themselves. So we can add x to both sides, we can add 4x squared to both sides, we can multiply both sides by x plus 1, so long as we don't multiply both sides by 0. Alright, so our first type of equation, and this would be the most basic one, would just be a linear equation. Now, a linear equation is whenever we have a linear expression equal to another linear expression. And linear expressions may only have constants, so real numbers, and multiples of x. Assuming that, of course, our variable is x. It would have constants and multiples of whatever variable we're talking about. So, very basic example would be something like 7x minus 2 is equal to 12. And all you need to do to solve linear equations is use the principles of addition and multiplication. Try to make sure you've got all of your x's on one side of the equation, and make sure you have all your constants on the other side of the equation. So we will add 2 to both sides and say, well, 7x, if we add 2, cancels the negative 2, 7x equals 14. And then our constant multiple that we're multiplying by here is 1 over 7. It's just basically the same as dividing by 7. And that leaves us 7 over 7, which is 1, a single x, and on the other side, 14 over 7 is 2. And we get our answer, x equals 2. Now, any linear equation, if you move everything to one side, a linear equation is always equivalent to something of the form ax plus b equals 0. Again, this is assuming that x is our variable. But if you were to have a different variable, like t for instance, then a linear equation would be at plus b. The main thing here is a and b are constants, x is our variable. Now there may be a few equations that are disguised a little bit, but are essentially linear equations themselves. Let me give you an example. Okay, here's an equation, 5 over x minus 2 equals 3 over x. Now before you do anything with this, just know that you can't divide by 0, so right off the bat we should just take a little note here that x cannot be allowed to equal 2, so we'll cross that equal sign out, and x cannot be allowed to equal 0 because we'll be dividing by 0 on one of the two sides otherwise. Now, it certainly doesn't look linear. It's not of the form ax plus b equals 0. So, how do you solve this? To make this actually look linear, we can cross multiply. When you have two rational expressions equal to each other, we can cross multiply, and that leaves you with 5 times x and equal to 3 times x minus 2. And now it starts to look a little bit more linear. 5x equals 3x minus 6. And sure enough, if you were subtracted and added and multiplied, you can solve this just with only the addition and multiplication principles. Let's subtract 3x from both sides. 2x equals negative 6. Divide both sides by 2, which is using the multiplication principle, but essentially multiplying by a half. That gives us x equals negative 3, and that's our answer. And we can double check against these two restrictions that we had initially, and it looks like x equals negative 3 is a value that is allowed in the original equation. So you must make that additional check simply because it wasn't written in linear form initially. Now, linear equations only need those two principles, and they are kind of treated differently than most other equations. Most of the time with linear equations, we want our x's on one side and we want all the constants on the other, and then your final step is usually just dividing by whatever coefficient is in front of the x. Now, that's pretty unique for linear equations. Most equations are a little bit trickier, and we actually want everything on one side of the equation. So let's take a look at quadratic equations next. Okay, first thing about quadratic equations to know is that they can always be written in the form ax squared plus bx plus c equals 0. So you can only have constants, this would be the c. You can have terms involving x, and if you combine those, you can get that b. And you can have terms involving x squared, and you can combine those and find the value of a. But you do want all of them on the one side of the equal sign, and you have a quadratic expression. And on the other side of the equal sign, we want 0. That's pretty important, and that makes this very different than linear equations, where we're quite happy to have x's on one side and constants on the other. Now, there are a couple different solutions or different methods for finding the solution to a quadratic equation. And the first one is using factoring. And that's why factoring in our one of our more recent videos is going to be so important here. It's using the zero product property. The idea here is once you have something factored, let's suppose you can take that ax squared plus bx plus c equals 0. Suppose that you can factor that. And maybe you have something, I'll use capital letters here, maybe you have something of the form ax plus b times cx plus d equals 0. Suppose that you can factor it. You'll notice that in each of those brackets we have only constants and terms with x, and those would be linear expressions that are multiplied together. Now, the only way that you can have real valued expressions to multiply together to equal 0 is if at least one factor is equal to 0. This is a major property of real numbers. There's just no way to multiply more than one real number together and get 0 without having one of those factors equal to 0. So the zero product property says ax plus b times cx plus d equals 0 if and only if one of the factors equals 0. This results in two other linear equations, and each of those linear equations you can solve as before, just using addition and multiplication principles. It's not always easy. Sometimes you have to factor using the AC method. And here's an example, 2x squared minus 5x minus 3 equals 0. If we try the AC method on this, and maybe you want to pause this video and try it for yourself first, then you can factor this one. Give it a try. The factors that you should find are 2x plus 1, x minus 3. The only way this can produce a product equal to 0 is if 2x plus 1 equals 0 or x minus 3 equals 0. Now we can use addition principles and multiplication principles all over again. 2x would have to equal negative 1, and that's only possible if x is equal to negative 1/2. What about x minus 3 equal to 0? That is only possible when x is equal to 3. That gives you two solutions. X is equal to negative 1/2, x is equal to positive 3. Two solutions for a quadratic equation. And as it turns out, quadratic equations can have two solutions, but they may actually have only one solution, or they may have 0 solutions. Now, to be able to factor these, you have to get a little bit lucky because we're always looking for two numbers that multiply to something but add to something else, and you may not be able to find those numbers. So either it's not always possible or it's not always easy, but luckily there is a way around that. If we want to take a look at the general form ax squared plus bx plus c, then we can actually go ahead and try to come up with a general way to find the values of x. Now you may be familiar already with something that we call the quadratic formula, and that is something that was discovered by going through a process called completing the square. Now, completing the square is a very tedious process for getting x by itself algebraically. Basically, just using factoring, the addition principle, and the multiplication principle, there is actually a way to try to get x by itself. But it's not the easiest process, and I may save that for another video. But luckily, due to a mathematician, Francois Viette, who decided, why don't we try to solve these things in general? Why don't we let these numbers in front of x and x squared, why don't we let those be symbolic, a, b, and c? And he worked with that, and other mathematicians have worked with other equations similarly to come up with just a clever formula that you can plug in values a, b, and c. So you may have seen this already, hopefully. This is called the quadratic formula. Now, the solutions to ax squared plus bx plus c can be found simply by making sure you've got a labeled as whatever number is in front of the x squared, b labeled as whatever number is in front of x, c labeled as whatever constant you have when you have the equation in this general form equal to 0. Once you have those three values, you can plug them in to the quadratic formula. And there is a plus or minus sign here. And with that plus or minus sign, you actually have to both add the value from the square root and subtract the value of the square root to get two different results. What is inside that square root, this b squared minus 4ac, actually has a very special name for it. b squared minus 4ac is called the discriminant. The discriminant will tell you whether you have 0, 1, or 2 solutions. You see, if b squared minus 4ac results in a value that is positive, then we can take the square root of it. And whatever value we get, we'll have negative b plus that value divided by 2a, and we'll have negative b minus that value divided by 2a. And that's what gives us 2 solutions. Now, if b squared minus 4ac is equal to 0, then we know that we can take the square root of 0 because there is a value where if we square it, its square equals 0. Remember, to find the square root of 0, you have to think, what number squared equals 0? Well, that number is 0. So the square root of 0 is equal to 0, and that's allowed. So when b squared minus 4ac is equal to 0, then the square root of the discriminant is 0, and adding or subtracting 0 won't change it to a different value. We get a single value for x, and that means we only have one solution. In fact, at that point, x would just be equal to negative b over 2a. Now, last but not least, we could have b squared minus 4ac be negative. In this case, 4ac would be larger than b squared, and the result ends up being below 0. Now, if that's the case, trying to square root a negative value doesn't give us a real solution. So we say this has got no solution. And so just using the discriminant, you can already know how many solutions there are, and then you can plug that discriminant into the root to be able to find the 2 or the 1 solution if they exist. I suppose there's probably one more way that you might try to solve a quadratic equation under very rare circumstances, and that would be if we have just an equation of the form ax squared plus c equals 0. And that would be only when the coefficient of the x term equals 0. Now in this case, it starts to look almost linear. The only difference is instead of x, we have x squared. Now don't panic, because I mean, you could just use the quadratic formula, or you might be able to factor this, depending on the values of a and c. However, there is maybe one thing you can do right off the bat. Let me give you an example of an equation that looks like this sort of form. Let's say that 3x squared minus 6 equals 0. Well, we can use the addition principle and get x by itself. We'll need to use the multiplication principle when we divide by 3. We're left with x squared equals 2. Now, you have to be a little bit careful here, because while you can square root both sides of the equation, the square root of x squared doesn't exactly cancel. If x is a negative number, then when you square it, it becomes positive, but the square root of a positive number is always positive. So in the result of this, you have essentially taken the absolute value of x. And if the absolute value of x is equal to 2, then there are actually 2 different values of x that could work here. With the absolute value of x equal to root 2, x is free to be positive or negative root 2, giving you 2 solutions. X is equal to positive root 2 or negative root 2. And so we'll just write plus or minus there. That leaves you with 2 solutions, even though it doesn't necessarily look that different from a linear equation. It's always the case that a quadratic equation can have at most 2 roots. Now, just as before, it's quite possible that you may have some sort of expression that looks rational. Maybe you have rational expressions on both sides of the equal sign, but by combining rational expressions and perhaps cross-multiplying, you might be able to show that something looks like a quadratic equation. So be careful with that. Try to do your best to simplify rational expressions first, cross-multiply if necessary, and then see what kind of expression you have afterwards. there's a decent chance it may be linear or quadratic, at least in this course. All right, well, we'll look at some other types of equations that may be a little bit more advanced than linear or quadratic, or maybe some examples that don't really appear quadratic at all, but is kind of similar to one. We'll look at those in a future video. Thanks for watching, and I'll see you then.